All right, we have a question here from a student, and I thought it would be a good one to do so that other students could benefit if they have the same question. Let's read. It says the test statistic of z equals negative 1.19 is obtained when testing the claim that p equals 4/7. A. What kind of critical values are we looking for? Using a significance level of alpha equals 0.05, find the critical values. B. Should we reject the null hypothesis or should we fail to reject the null hypothesis? So for part A, what kind of critical value or values are we looking for? The way we know how to answer this question is the fact that we're testing a claim about a proportion. When you test a claim about a proportion, you will always be using z-scores for the critical value and the test statistic. So we know it's going to be z-scores. But the other thing we have to consider is what kind of tails we should have. Now, if we have a claim that has equality in it, and it has the equal sign specifically in this example, that means that our null hypothesis will contain the claim, and the alternative will be the complement of the claim, not equal. So this will be a two-tailed test. When we have a two-tailed test, we have to have two critical values. So we would be looking for two z-scores, one positive and one negative. Part B, we're asked to give the absolute value of the critical values. So we're going to find the z-score using this alpha 0.05. So with two tails, our z-score boundary for the critical values, we're going to have two, one on each side. So these will be our critical values. The area in each tail is half of alpha, 0.025. So looking up an area of 0.025 in the table, where's my little table? There we go. In the z-score table, looking up an area in the body of the table of 0.025, right here. Oh no, that's 0.0025. We want just 1025. Here we go. All right, so we have the area of 0.025 lining up with a z-score of negative 1.96. So this is negative 1.96 over here, and this is positive 1.96. And we've been asked for the absolute value, so the answer is positive 1.96. You can also do this with Excel. So if we have a left area of 0.025, and we want to find the critical value that is a z-score, we will use the norm. Now, one of these is distribution, one of them is inverse. When you're looking for an area, you use distribution. When you're looking for a boundary, you use inverse. The probability on the left, the mean of 0 for all z-scores, and the standard deviation of 1 for all z-scores. And there you have negative 1.96. The absolute value of this is positive 1.96. Okay, let's go back and see what else we have in this question. Choose the correct conclusion below. Either reject the null and there is not sufficient evidence to support the claim, reject the null and there is sufficient evidence to warrant rejection of the claim, fail to reject the null hypothesis, there is not sufficient evidence to warrant rejection of the claim, or fail to reject, there is sufficient evidence to support the claim. Okay, so a couple different things here. First of all, we need to determine if we are rejecting the null hypothesis or not. Then we will determine what that means about the claim. And we might be talking about supporting the claim. Either there is or there is not sufficient evidence to support the claim. Or we might be talking about rejecting the claim, and that depends on where the claim falls. In this example, the claim fell under the null hypothesis, which is vulnerable to being rejected. So if we reject the null hypothesis, then we would be rejecting the claim. If we fail to reject the null hypothesis, then we would fail to reject, or we would not warrant rejection of the claim, I guess is how you're supposed to say it. But how are we going to make this decision? Well, it told us that a test statistic was obtained of negative 1.19. So let's go ahead and draw that into the picture. Negative 1.19. That is to the right of the critical value on the left side. That's our test statistic. And the p-value is to the left of that. Now, we don't need the p-value in order to make a decision. What we see is that the test statistic does not fall in the rejection region, the red region. So for that reason, we would say fail to reject the null hypothesis. So it's definitely going to be one of the two choices that start with fail to reject the null hypothesis. So it's one of these two. Now, if you wanted to, if you like using the p-value method, you could figure out the p-value from here. You don't need to. We can already see in the sketch that the test statistic is not in the rejection region. But if you were trying to find the p-value, what you would do is you would take your test statistic, z equals was it negative 1.19, I believe? And then you would find half of the p-value, and it's only half this time because it's a two-tailed test. If we were doing a single-tailed test, then our p-value would be just the one area. But whatever we find to the left of this test statistic is going to be half of our p-value since this is a two-tailed test. Then we will use the norm distribution since this time we're looking for an area using the z-score boundary. Remember that this is always going to give you the area to the left. And so my entire p-value is actually twice that amount. And notice that the p-value is not less than our significance level alpha. Alpha was given to be, where'd the problem go? Alpha was given to be 0.05. And if the p-value is less than the area in the red, then we will reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So 0.117 is half the p-value. What just happened? 0.117, that's half of my p-value, and my total p-value is 0.234, which we look to see if it is less than alpha 0.05, and notice that it is not. So we fail to reject the null hypothesis based on that as well. All right, now, once you've decided that you're failing to reject the null hypothesis, just write that here, fail to reject H sub 0, then you determine what that means about the claim. And as I said, since our claim is in the null hypothesis and we are not rejecting the null hypothesis, then we are not rejecting the claim. So we'll look for the one that says there is not sufficient evidence to warrant rejection of the claim. So that's why this is the best choice right here. Now, even if you didn't reason that out on your own, you could use the flowchart in the formula packet. On the back side of your formulas, all the way to the bottom right corner. So we'll say First, we determine if the original claim contained the condition of equality. The claim was that the proportion was equal to 4/7. So because there was equality in the claim, we will answer yes to this question. So the original claim contains equality. Do we reject the null hypothesis? No, we failed to reject. Therefore, our conclusion should say something like there is not sufficient evidence to warrant rejection of the claim. All right, so that concludes this video. Hopefully it was helpful. If you have questions, you can always email me, and I hope you're doing well. Take care.